Let's learn our 6 times table. 0 times 6 is 0. 1 times 6 is 6. 2 times 6 is 12, because if we have two groups of 6, we have 12 counters altogether. 3 times 6 is 18, because if we have three groups of 6 counters, we have 18 counters altogether. 4 times 6 is 24. 5 times 6 is 30. 6 times 6 is 36. 7 times 6 is 42. 8 times 6 is 48. 9 times 6 is 54. 10 times 6 is 60. 11 times 6 is 66. And 12 times 6 is 72. Now we need to connect the 3 times table and the 6 times table. Every number that's in the 6 times table is also in the 3 times table. Every multiple of 6 is also a multiple of 3. So on this top number line, we can show the 3 times table, and on this number line down here, we can show the 6 times table. So we have 3, then 6, and then the 6 times table, we start with 6. Now we've got 6 counters altogether for 2 times 3, and we've got 6 counters for 1 times 6. Now if we keep going, we have 9, and then 12, and if we keep going with our 6 times table, 2 times 6 is 12. You can see that we've now got 6 more counters in our 3 times table, and then of course we've got another 6 counters in our 6 times table as well. If we continue counting in 3s, we have 15 and then 18, and the next multiple of 6 is also 18. We've made 6 more counters in our 3 times table by jumping to 15 and then 18, and of course we've got 6 more counters for our 6 times table. Then the next multiples of 3 are 21 and 24, and 24 is also the next multiple of 6. We have 6 counters here and 6 more counters in our 6 times table. If we keep counting, we get 27 and then 30, and 30 is the next multiple of 6 as well. We can continue 33 and then 36, so 12 times 3 is 36, but 6 times 6 is also 36. To finish off our 6 times table, we get 42, then 48, 54, 60, 66, and 72. And all of these numbers would also be in our 3 times table if we kept on counting in 3s. Now to see the connection here, we have our 3 times table and our 6 times table written out. If we double what's in the 3 times table, we get what's in the 6 times table. Remember, we double by adding a number to itself or multiplying by 2. So 3 times 2 is 6, 6 times 2 is 12, 9 times 2 is 18, and so on. Or, looking at it the other way, if we halve what's in the 6 times table, we get what's in the 3 times table. Remember, we find half of a number, or halve a number, by dividing it by 2. 6 divided by 2 is 3, 12 divided by 2, or half of 12, is 6, 18 divided by 2, or half of 18, is 9, and so on. You can see that numbers in the 6 times table are always also numbers in the 3 times table. So we have 6 as 1 times 6 and 2 times 3. We have 12 as 2 times 6, or 4 times 3. we have 18 as 3 times 6, or 6 times 3. We have 24 as 4 times 6, or 8 times 3. And spot that 8 is double 4, 2 times 4 is 8. We have 30 in both the 6 and the 3 times table, and we have 36. And if we continued counting in threes, we would have all our other numbers that are in the 6 times table in the 3 times table as well, if we kept on writing out our 3 times table after 12 times 3. So you can see that if we count in threes twice, we've counted in sixes. We have 6 counters altogether. If we count in threes again twice, we have the same as 2 times 6. So 2 times 3 plus 2 times 3 is 2 times 6. If we keep counting, we have 18 counters altogether because we've got 9 counters twice, and notice 3 times 6, the third multiple of 6, is 18. We can keep on going, so if we have 12 counters twice, we have 24 counters, doubling the 3 times table, so showing the 3 times table twice shows us the 6 times table, because we can see that in each of our lines downwards, we have 1, 2, 3, 4, 5, 6 counters altogether. So we can keep going, because 5 times 6 is 30, then 6 times 6 is 36, 7 times 6 is 42, and 42 is double 21. If we do 21 times 2, or 21 plus 21, we get 42. 8 times 6 is 48. 9 times 6 is 54. 10 times 6 is 60, so that's double 10 times 3. If we show 10 times 3 twice, we've shown 10 times 6. Then we have 66 for 11 times 6, and 12 times 6 is 72. Or we can show it the other way. If we have our 6 times table, we can split the counters that we have in half, so get rid of half of our counters, and then we have the 3 times table. Or on a 100 square, we can colour in all multiples of 3. So if we kept on counting up in threes after 36, we would have all the numbers that are coloured in blue here. Now if we show the 6 times table, we can see that all multiples of 6, so all the numbers that are coloured in now, were also coloured in when we were colouring in our multiples of 3. Now let's learn our 7 times table. 0 times 7 is 0. 1 times 7 is 7. 2 times 7 is 14, because if we have 2 groups of 7 counters, we have 14 counters. 3 times 7 is 21, because if we have 3 groups of 7 counters, we have 21 counters altogether. 4 times 7 is 28. 5 times 7 is 35. 6 times 7 is 42. 7 times 7 is 49. 8 times 7 is 56. 9 times 7 is 63. 10 times 7 is 70. 11 times 7 is 77. And 12 times 7 is 84. Now let's learn our 9 times table. 0 times 9 is 0. 1 times 9 is 9. 2 times 9 is 18, because if we have 2 groups of 9 counters, we have 18 counters altogether. 3 times 9 is 27, because if we have 3 groups of 9 counters, we have 27 counters. 4 times 9 is 36. 5 times 9 is 45. 6 times 9 is 54. 7 times 9 is 63. 8 times 9 is 72. 9 times 9 is 81. 10 times 9 is 90. 11 times 9 is 99. And 12 times 9 is 108. Now let's learn our 11 times table. 0 times 11 is 0. 1 times 11 is 11. 2 times 11 is 22. 3 times 11 is 33. 4 times 11 is 44, and you're probably spotting a pattern here. When we count in steps of 11, the tens digit goes up by 1, and so does the ones digit. And the reason why we get that is that when we count in steps of 11, we're adding 1 10 and 1 1 each time. 5 times 11 is 55. 6 times 11 is 66. 7 times 11 is 77. 8 times 11 is 88. 9 times 11 is 99. 10 times 11 is 110. 11 times 11 is 121. And 12 times 11 is 132. Now let's learn our 12 times table. 0 times 12 is 0. 1 times 12 is 12. 2 times 12 is 24, because if we have 2 groups of 12 counters, we have 24 counters altogether. So here we can see 2 tens and 4 ones. 3 times 12 is 36, because if we have 3 groups of 12, we have 36 counters altogether. 4 times 12 is 48. 5 times 12 is 60. 6 times 12 is 72. 7 times 12 is 84. 8 times 12 is 96. 9 times 12 is 108. 10 times 12 is 120. 11 times 12 is 132. And 12 times 12 is 144. Now for these questions, we need to multiply a single digit number and a multiple of 10, so a number that ends in a 0. First, we have 3 times 60. That's 180, because 3 times 6 is 18. But then, if we have one end 0 in a multiplication question, there will be one end 0 in the answer. And that makes sense if we think that 60 is 6 tens. So if we multiply 3 by 6 tens, we will get 18 tens, and 18 tens is the same as 108 tens. Now we have 90 times 7. That's 630, because 9 times 7 is 63, and then again, if we have one end 0 in the question, there will be one end 0 in the answer. So now let's try 9 times 70. Our answer is 630 again, because 9 times 7 is 63. And if we have one end zero in a multiplication question, there will be one end zero in the answer. So let's look again at this first question. We had 3 times 60. So let's count on a number line in steps of 60 3 times. We have 60, 120, and then 180. So because we made 3 jumps of 60, we know that 3 times 60 is 180. And that makes sense because here you can see that we have 18 tens altogether. Counting in steps of 60 is just like counting in steps of 6, but we have a 0 as our ones digit because 60 is 6 tens. Then we had 90 times 7. If we count in steps of 90, we have 90, 180, 270, 360, 450, 540, and then the 7th multiple of 90 is 630. So that's why 90 times 7 is 630. Counting in steps of 90 is just like counting in steps of 9, but with a 0 in our ones digit. Then we had 9 times 70. If we count 9 steps of 70, we have 70, 140, 210, 280, 350, 420, 490, 560, and then the 9th multiple of 70 takes us to 630, so that's our answer. And again, counting in steps of 70 is just like counting in steps of 7, but with a 0 in the ones, because we're counting not in ones, but in steps of 7 tens, or 70. Now, let's multiply a single-digit number and a 2-digit number using the grid method. First, we have 4 times 66. What we need to do is partition our 2-digit number into tens and ones. So this 6 stands for 60 and this 6 stands for 6. So what we can do is multiply 4 by 60, then multiply 4 by 6, and then add up our answers. So we can write our single-digit number on the left of our grid and our partitioned number, so 60 and 6, on top. Now, for this box here, we need to work out 4 times 60. That's 240, because 4 times 6 is 24, and then we need our end 0, because in 60 we have 6 tens. And now for this box here, we need 4 times 6, so that's 24. So now all we need to do is add up our answers, and 240 plus 24 is 264, so that's our answer. Now we have 79 times 6. We can partition 79 into 70 and 9. So now what we can do is multiply 6 by 70, then multiply 6 by 9, and then add up our answers. So again, we can have our single-digit number on the left of our grid and our partitioned number, so 70 and 9, on top. Now 6 times 70 is 420, because 6 times 7 is 42, and then we need our end 0. And here we need 6 times 9, which is 54. So now we add our answers, and 420 plus 54 is 474, so that's our answer. Now if we look at this first question again, we had 4 times 66. Now we can show 66 using place value counters. We have 6 tens and 6 ones. And because the other number in our multiplication is 4, we can show 66 2, 3, 4 times. So now we have 24 ones, but we can regroup those into 2 10s and 4 1s. And we can regroup our 10s as well, because 10 10s can be exchanged for 100. So now you can see that we have 2 hundreds, 6 10s and 4 1s, so that's 264. Then we had 79 times 6, so we can show 79 as 7 10s and 9 1s. We're multiplying by 6, so we can show 79 2, 3, 4, 5, 6 times. So now we can regroup 10 1s to make 1 10. And we can regroup 10 10s to make 100. And when we do that, you can see that we now have 4 hundreds, 7 10s and 4 1s. So that's 474. Now for this first question, we needed to work out 4 times 66. But if we add the 60 times table and the 6 times table, we get the 66 times table. So we could work out that 4 times 60 is 240 and 4 times 6 is 24. And that means that 4 times 66 is the total of 240 and 24. So that's 264. Then our next question was 79 times 6, which is the same as 6 times 79. Again, if we add the 70 times table and the 9 times table, we get the 79 times table. So we could work out 6 times 70 and then 6 times 9, and adding up those answers gave us the answer to 6 times 79. Now we need to multiply a 2-digit number by a single-digit number using expanded column multiplication. So first we have 63 times 7. We can write this question out with our 2-digit number, so our larger number on top, and then our single-digit number below. Now here we have 2 answer lines. That's because on this first answer line, we're going to multiply our 1's digits, so multiply 3 by 7. Then on this second answer line, we're going to multiply the 6 that's in our 10's by 7. And finally, we're going to add up our answer lines to get our answer. So first, 3 times 7 is 21. And then we can write a 0 in our 1's digit of our second answer line. And that's because we're multiplying by the 6 that's in our 10's. So now 6 times 7 is 42. And you'll notice 420 is the answer to 60 times 7. Because remember, the 6 in 63 stands for 6 10s, so 60, and 60 times 7 is 420. So now we can add up our answer lines. 1 plus 0 is 1, 2 plus 2 is 4, and nothing plus 4 is 4. So our answer is 441. Now we have 76 times 9. So we can write the question out with our 2-digit number on top. Now for this first answer line, we're going to multiply our 1's digits, and 6 times 9 is 54. So now we can write a 0 as the last digit of our second answer line, and that's because we're going to multiply this 7 that's in our 10's. 7 times 9 is 63, so now we just add up our answer lines. 4 plus 0 is 4, 5 plus 3 is 8, and nothing plus 6 is 6. So our answer is 684. Now 89 times 6. On our first answer line, we need the answer to 9 times 6, so that's 54. Then we can write a 0 in our second answer line as our 1's digit because we're going to multiply the 8 that's in our 10's. 8 times 6 is 48, so now we can add up our answer lines. 4 plus 0 is 4, 5 plus 8 is 13, so 1, 3, and 1 plus 4 is 5, so we have 534. If we look back at this first question, we had 63, so that's 6 tens and 3 ones, and we were multiplying by 7. So we can show 63 2, 3, 4, 5, 6, 7 times. Now you can see that if we add up the ones, we have 21, and if we add up how many tens we have altogether, we have 42 tens, so that's 420, and putting it together gives us our answer, 441. Then we had 76 times 9. So we can show 76 as 7 tens and 6 ones. And we're multiplying by 9, so let's show that 2, 3, 4, 5, 6, 7, 8, 9 times. Now you can see that we have 54 ones blocks and we have 63 tens blocks, and 63 tens is the same as 630. So altogether we have 684. Then we had 89, so that's 8 tens and 9 ones, and we were multiplying by 6, so let's show that 2, 3, 4, 5, 6 times. On top here we have 54 ones counters, and below we have our 48 tens counters, so that's 480. And putting those together gives us 534 as our answer. We can also show multiplication using place value counters. So we start with 63 for this first question, so 6 tens and 3 ones, and to multiply by 7, we can show these place value counters 2, 3, 4, 5, 6, 7 times. Now we have 21 ones, but we can regroup those into 2 tens and 1 1. And we can regroup our tens as well. We can exchange 10 tens for 100. So that means altogether we now have 4 hundreds, 4 tens and 1 1. So that's 441. Then we had 76, so 7 tens and 6 ones, and we were multiplying by 9. So we can show what we have, 2, 3, 4, 5, 6, 7, 8, 9 times. Now we can regroup our ones because 10 one counters has the same value as 1 10. And now we can regroup our tens because if we have 10 tens, that's the same as 100. So now that we've regrouped as much as we can, we now have 6 hundreds, 8 tens and 4 ones, so that's 684. Our last question was 89, so 8 tens and 9 ones, and we were multiplying by 6, so we can show what we have 2, 3, 4, 5, 6 times. Now we can regroup 10 ones for 1 10, and we can regroup 10 tens for 100. So now that we've regrouped as much as we can see that we have 5 hundreds, 3 tens and 4 ones. So that's why our answer is 534. Now we need to multiply a 2-digit number by a single-digit number, and this time we're going to use short multiplication. So first we have 72 times 6. So we can write the question out with our 2-digit number on top and our single-digit number below. And because we're using short multiplication, we only need one answer line. So first, we need to multiply our ones digits. 2 times 6 is 12, but we can only have one digit in each place value, and 12 is a 2-digit number. So, because 2 times 6 is 12, we need to write 12 as 1, 2, so with the first digit above the next place value column along. Then we have 7 times 6, which is 42, But what we need to do now is add the 1 that we've written on top. So 7 times 6 is 42, plus 1 is 43. Now here, we don't have any more digits to multiply, so we can just write the 43 in our answer line. So our answer is 432. Now we have 28 times 9, so we can set the question out in the same way, and as always, we start by multiplying our ones digits. We have 8 times 9. That's 72, but again, we can only have one digit in each square or in each place value, so we need to write our answer to 8 times 9, so write 72 as 7, 2. So with the first digit above the next place value column along, so above our tens digit. And that makes sense if we remember that in 72 we have 7 tens and 2 ones, so we write the tens above our tens digit. So now we need to multiply this 2 that's in our tens by 9. 2 times 9 is 18, but we need to add the 7 that we've written above. So 2 times 9 is 18, and 18 plus 7 is 25. We don't have any more digits to multiply, so we can just write the 25 in our answer, so that's 252. Now we have 7 times 76. Although the single digit number is written first, remember with multiplication, order doesn't matter, so we can set the question out in exactly the same way as we've done above, so with our 2-digit number, the number with the most digits on top. Again, we need to multiply our ones digit first, and 6 times 7 is 42, so that's 4, 2, with the first digit above the next place value column along. So now we multiply our tens digit. 7 times 7 is 49, but we need to remember to add the 4 that's on top, and 49 plus 4 is 53. We don't have any more digits to multiply, so we can just write the 53 in our answer. So that's 532. Now let's have another look at this first question. We can show place value counters to represent the multiplication. So with 72, we have 7 tens and 2 ones. We were multiplying by 6, so we can show 72 2, 3, 4, 5, 6 times, because 6 is what we're multiplying 72 by. So we get 432, and that makes sense if we remember that we can regroup 10 ones to make one 10. So that's why we have the 1 written above our tens and just 2 in our ones answer line. But now we can regroup our tens as well. We can regroup 10 tens to make 100, and we can do that 4 times. So now that we've regrouped, we've ended up with 4 hundreds, 3 tens and 2 ones. So that's why our answer is 432. Our next question was 28 times 9. So we can represent 28 with 2 tens and 8 ones. We were multiplying by 9, so let's show the 28 9 times. We can multiply by 2, 3, 4, 5, 6, 7, 8, 9. But now we just need to do a lot of regrouping. We can regroup 10 ones to make one 10. And we can do that 7 times. That's because 8 times 9 is 72, but because we've regrouped into 7 tens and 2 ones, we can write the 7 above our tens column and the 2 in our ones answer line. Now we can regroup 10 tens to make 100, and we can do that twice. So now that we've regrouped as much as we can, we have 2 hundreds, 5 tens and 2 ones, so that's 252. Our last question was 7 times 76, but with multiplication, order doesn't matter. We can show 76 as 7 tens and 6 ones, And because the other number in our multiplication is a 7, we can show these place value counters 7 times. 2, 3, 4, 5, 6, 7. Now we can regroup. 10 ones makes 110, and that's why we get 42, but we write the 4 above our tens column because we only now have 2 ones. But now we can regroup our tens as well. 10 tens is the same as 100. So now that we've regrouped as much as we can, we have 500 counters, 3 10 counters, and 2 1 counters. So that's 532. Now we need to multiply 3 numbers together. But with multiplication, we can multiply in any order. So first, we have 3 times 8 times 9. But because we can multiply in any order, we could start by multiplying the larger numbers first. 9 times 8 is 72, but then we need to multiply our answer to that, so multiply 72 by the other number in our question. So we need to work out 72 times 3. 2 times 3 is 6, and 7 times 3 is 21. So our answer to 3 times 8 times 9 is 216. Now we have 8 times 6 times 5. If we work out 8 times 6 first, that gives us 48. And then we can take that answer, so take the 48, and multiply it by the other number in our question. 8 times 5 is 40, so using short multiplication, we can write 40 as 40, so with the first digit above the next place value column along, so above our tens digit. Now we can multiply our tens digit, and 4 times 5 is 20, but we need to add the 4 that's on top. So 4 times 5 is 20, plus 4 is 24, and we don't have any more digits to multiply, so we can just write 24 in our answer line. So that means that 8 times 6 times 5 is 240. Now there was a quicker method here. If we'd have first multiplied 8 by 5, that would give us 40, and then we could take that 40 and multiply it by the other number in our question, so by the 6, and we could do that without having to use short multiplication. Our answer is 240, because 4 times 6 is 24, and if we have an end zero in a multiplication question, we will have an end zero in our answer. So it's quicker to see if any numbers multiply together to give an answer with 0 ones, because then we don't need to use column method, we can work our answer out mentally. So now we have 6 times 7 times 5. If we start by multiplying larger numbers first, 7 times 6 is 42, and then we can take that answer and multiply it by the other number in our question. 2 times 5 is 10, so 10, with the first digit on top. And then we multiply our tens digit. 4 times 5 is 20, but we need to add the one that's on top, so that's 21. So that means 6 times 7 times 5, that's 210. But again, like with this question, we could have solved this more quickly if we'd spotted that 6 times 5 is 30. And because 30 is a multiple of 10, because it ends in a 0, we can easily multiply it by the other number, so by the 7, and 30 times 7 gives us the same answer. That's 210, because 3 times 7 is 21, and then if we have an end zero in a multiplication question, we need an end zero in our answer. Now we need to multiply a single digit number by 100. First we have 3 times 100. That's 300, because 3 times 1 is 3, and then if we have 2 end zeros in a question, we have 2 end zeros in our answer. Now we have 100 times 5. That's 500, because 1 times 5 is 5, and then we have 2 end zeros in the question, so we need 2 end zeros in our answer. And now 8 times 100 is 800, because 8 times 1 is 8, and then we need 2 zeros after the 8. So what's really happening when we multiply by 100 is that digits are moving 2 place values to the left. So first we had 3, so 3 ones, and when we multiply by 100, this 3 moves 2 place values to the left. But now, to show that it's in our hundreds place value, we need zeros in our tens and ones. And for 100 times 5, we can write 5 in our ones, but then to multiply it by 100, we're moving 2 place values to the left, and now to show that the 5 stands for 500s, we need zeros in our tens and ones. And for 8 times 100, it's the same thing. The digit moves 2 squares or 2 place values to the left, so we can put 2 zeros on the end to get our answer. Now the reason why the digits move 2 squares to the left when we multiply by 100 is because multiplying by 100 is like multiplying by 10 and then by 10 again, because 10 times 10 is 100. So we know that 3 times 10 is 30, but then if we have 30 times 10, we have 300. We know that 5 times 10 is 50, but then we can take that 50 and multiply it by 10 again, and that gives the same answer as multiplying it by 100. Then 8 times 10 is 80, and we can take that answer, multiply it by 10 again, and we get 800. So we know that multiplying by 10 moves the digits 1 square to the left, and if we multiply by 10 again, we can move it another square to the left, and that's why when we multiply by 100, which has 2 zeros on the end, we can just put 2 zeros on the end of our number to get our answer. So for 3 times 100, we can show 3, and if we make these 3 counters 100 times bigger, we get 300. For 5 times 100, we can do the same thing to get 500, and for 8 times 100, we can show 8 1 counters, but if we multiply by 100, we get 800. Now for these questions, we need to multiply a single digit number and a multiple of 100, so a number that ends in 2 zeros. First, we have 3 times 300. That's 900, because 3 times 3 is 9, so we can multiply the non-zero digits in our question, but then because we have 2 end zeros in a multiplication question, we need 2 end zeros in our answer. So now let's try 500 times 5. Our answer is 2500, because if we multiply the digits that are not 0, 5 times 5 is 25, but then because we have 2 end zeros in the question, we need 2 end zeros in our answer. And now 8 times 800 is 6400. That's because 8 times 8 is 64, and then if we have 2 end zeros in a multiplication question, we always need 2 end zeros in our answer. Now to see why this works, remember 300 is the same as 3 times 100. So instead of working out 3 times 300, what we're really doing is working out 3 times 3 and then multiplying our answer by 100. So 3 times 3 is 9, and then to multiply by 100, we can put 2 zeros on the end, because what's really happening is that the digit moves 2 place values to the left, and now to show that it's in our hundreds column, we need zeros in our tens and ones. Now 500 is 5 times 100, but we can multiply in any order. So first we can work out 5 times 5, that's 25, and then we can multiply by 100 by moving the digits 2 squares or 2 place values to the left and writing zeros in our empty place values. And that's why we can multiply the non-zero digits in the question and then put 2 zeros on the end of our answer. Now we had 8 times 800. 800 is the same as 8 times 100. So we could do 8 times 8 first to get 64, and then we could put 2 zeros on the end because multiplying by 100 moves the digits 2 place values to the left. Now we need to multiply a single digit number and a 3-digit number using the grid method. So first we need to partition our 3-digit number into hundreds, tens and ones. So this 1 stands for 100, this 2 for 20 and this 3 for 3. So now we can write the numbers onto our grid. We can have the single digit number in the question on the left and then our partitioned number, so 100, 20 and 3 on the top. Now for this box here we need to work out 100 times 5. That's 500 because 1 times 5 is 5, and if we have 2 end zeros we need 2 end zeros in our answer. Now for this box we need to work out 20 times 5. That's 100 because 2 times 5 is 10, but then if we have 1 end zero in our question, we need 1 end zero in our answer after we've written the answer to 2 times 5. Now for this box here, we have 3 times 5, so that's 15. Now all we need to do is add up our answers. 0 plus 0 plus 5 is 5, 0 plus 0 plus 1 is 1, and 5 plus 1 is 6. So our answer is 615. Now we have 234 times 4. So this 2 stands for 200, this 3 for 30, and this 4 for 4. So we can have the single digit number in our question on the left and our partitioned number on top. Now for this box we need to work out 200 times 4. That's 800 because 2 times 4 is 8, and if we have 2 end zeros in the question, we need 2 end zeros in our answer. Now here we need to work out 30 times 4. That's 120 because 3 times 4 is 12, and if we have 1 end zero in a multiplication question, we need 1 end zero in our answer. And now finally for this box we just need 4 times 4, which is 16. So we can add up our answers and that gives us 936. Now to see why this method works, let's show place value counters. So we partitioned 123 into 100, 2 tens or 20 and 3 ones. Multiplying by 5, we can show the 123 2, 3, 4, 5 times. So now you can see that we have 15 ones, which we can regroup into 1 10 and 5 ones. We have 10 tens plus the 10 that we made from multiplying our ones, but we can regroup 10 ones into 100. So altogether we have 6 hundreds, 1 10 and 5 ones. So that's why our answer is 615. Then for this question, we had 234, so that's 2 hundreds, 3 tens and 4 ones. We were multiplying by 4, so let's show these place value counters 4 times. Now we have 16 ones, which we can regroup into 1 10 and 6 ones. We can also regroup 10 of these tens into 100. So now we have 9 hundreds, 3 tens and 6 ones. So that's 936. We could also show what we did using base 10 blocks. So first we had 5 times 123. We wrote 5 on the left and 100, 20 and 3 on top. Now for this box here, we needed 5 hundreds, so we can show a 100 block 5 times, and that gives us 500. Now here, we needed 5 lots of 20, so we can show 2 10 blocks 5 times, and that gives us 10 tens altogether, which is the same as 100. And here, we had 5 times 3, so we can show 3 blocks 5 times, and that gives us another 15. So if we add what we've made, that comes to 615, so that's our answer. Then we had 234 times 4. So we wrote 4 on the left and 200, 30 and 4 on top. Now for this box here, we needed to multiply 200 by 4. So we can show 2 hundreds 2, 3, 4 times, and that gives us 800. Now here we needed to multiply 30 by 4, so we can show 30 or 3 tens 4 times, and that gives us 12 tens, and that's the same as 120. And here we needed to multiply 4 by 4, and that gives us another 16. So then we added together what we'd made, and that came to 936. So now let's try 2 more questions. We have 4 times 255. We can partition this number into 2 hundreds, 5 tens and 5 ones. So we can write the single digit number in the question on the left and our partitioned number on top. Now here we need to work out 200 times 4. That's 800 because 2 times 4 is 8, and then if we have 2 end zeros in a multiplication question, we need 2 end zeros in our answer. Now here we have 50 times 4, which is 200 because 5 times 4 is 20, but after we've written the 20, we need to write another 0 because we have 1 end zero in our multiplication question. And here we have 5 times 4, which is 20. So now, if we add up what we've made, that comes to 1020. Now, let's try 652 times 9. We need to partition our 3-digit number. This 6 is in our hundreds, so stands for 600. This 5 is in our tens, so stands for 50. And this 2 is in our ones, so stands for 2. Now we can write our numbers on the grid, and here we need to solve 600 times 9. That's 5,400 because 6 times 9 is 54, and then we need 2 end zeros. Here we have 50 times 9, which is 450. 5 times 9 is 45, and then we need our end zero. And here 2 times 9 is 18. So we can add up the numbers that we've written on the grid, and that gives us our answer, 5,868. Now we need to multiply a 3-digit number by a single-digit number, and we're going to use the expanded column method. First, we have 353 times 2. So we can write our question out with the larger number or the number with the most digits on top, but this time we're going to need 3 answer lines. That's because on this first answer line, we're going to multiply our ones digit. Then on the second answer line, we're going to multiply our tens digit. And on our third answer line, we're going to multiply our hundreds digit. Then we're going to add up our answer lines to get our answer. So first, multiplying our ones digit, 3 times 2 is 6. So now we can write a 0 on the end of our second answer line. And that's because we're going to multiply by our tens digit, so we need a 0 in our ones. 5 times 2 is 10. So moving on to our third answer line, we need 2 zeros in our tens and our ones columns. That's because we're multiplying by the 3 that's in our hundreds, so we need zeros in smaller place values. 3 times 2 is 6, so now all we need to do is add up our answer lines, and we have our answer 706. Notice the reason why we could write a 0 in our second answer line is because 5 tens is the same as 50, and 50 times 2 is 100. But if we write a 0 at the end, we don't need to multiply 50 by 2, we can just multiply 5 by 2 and get the same answer. And here, for our third answer line, we could write zeros in our tens and ones, because this 3 is in our hundreds, so stands for 300, and 300 times 2 is 600. But because we'd already written zeros in our tens and ones, we just had to do 3 times 2 to get 6. So now let's try 457 times 5. For our first answer line, we need to multiply our ones digit, and 7 times 5 is 35. Now we can write a 0 on the end of our second answer line, so in our ones, because we're going to multiply our tens digit, and 5 times 5 is 25. Now remember, for our third answer line, we need 2 zeros in our tens and our ones, because we're multiplying by the 4 that's in our hundreds. 4 times 5 is 20, so now if we add up our answer lines, we get 2,285. Now we have 293 times 7. 3 times 7 is 21. We write a 0 in our second answer line, and now 9 times 7 is 63. We write 2 zeros in our third answer line, and now 2 times 7 is 14. So now 1 plus 0 plus 0 is 1, 2 plus 3 plus 0 is 5, 6 plus 4 is 10, so that's 1 0, and 1 plus 1 is 2. So we get 2051. So let's take another look at this first question. We had 353. So in 353, we have 3 hundreds, 5 tens, and 3 ones. We were multiplying by 2, so we can show the place value counters that we have 2 times. Now we have 10 tens, but we can regroup 10 tens into 100, and that gives us our answer 706, because now we have 7 hundreds, no tens, and 6 ones. Then we had 457, so that's 4 hundreds, 5 tens, and 7 ones, and we were multiplying by 5, so we can show 457 2, 3, 4, 5 times. Now we can regroup 10 ones into 1 10, we can regroup 10 tens into 100, and we can regroup 10 hundreds into 1000. And when we do the regrouping, you can see that we have 2 thousands, 2 hundreds, 8 tens, and 5 ones. So that's why our answer is 2,285. Now we need to multiply a 3-digit number by a single-digit number, and this time we're going to use short multiplication. First, we have 167 times 4. So we can set the question out with the larger number on top, but because we're using short multiplication, we only need one answer line. Now we start by multiplying digits in the smaller place values, so we start by multiplying our ones. we have 7 times 4. That's 28, but we can only write one digit in each square. So we need to write 28 as 2, 8. So with the first digit above the next place value column along, so above our tens digit. So now we can move on to multiplying our tens digit by 4. 6 times 4 is 24, but now we need to add the 2 tens that we made from multiplying our ones. So 6 times 4 is 24, plus 2 is 26. And again, we need to write 26 as 2, 6. So with the first digit above the next place value column along. Now we can move on to multiplying our hundreds. 1 times 4 is 4, and we need to add the 2 that's on top, and 4 plus 2 is 6. Now we don't have anything else to multiply, so we have our answer. That's 668. Now we have 879 times 3, so we can set the question out in the same way, and we start by multiplying our ones. 9 times 3 is 27, so that's 2, 7, with the first digit above the next place value column along. Now 7 times 3 is 21, but we need to remember to add the 2 that's on top, to add the 2 tens that we made by multiplying our ones digit. So 7 times 3 is 21, and 21 plus 2 is 23. We need to write that 2, 3. So again, with the first digit above the next place value column along. And now 8 times 3 is 24, plus 2 is 26. Now this time we can just write the 26 in our answer line, even though it's a 2-digit number. And that's because we don't have any more digits to multiply. We don't have a 1,000 digit, so we can just write our 26 in our answer. So that's 2,637. Now we have 4 times 867. Now here, though the single digit number is written first, we can set the question out in the same way. Because remember, with multiplication, order doesn't matter. And when we're using short multiplication, we need the larger number on top. So now 7 times 4 is 28, so that's 2, 8. 6 times 4 is 24, plus 2 is 26, so 2, 6. And now 8 times 4 is 32, plus 2 is 34. We don't have a 1,000 digit in our question, so we can write the 34 in our answer line to give us 3,468. So to understand why this method works, let's take a look at this first question again. We had 167, so that's 100, 6 tens, and 7 ones. We were multiplying by 4, so we can show 167 4 times. Now we have 28 ones, but we can regroup 10 ones and make 1 10. And when we do that, we now have 2 tens and 8 ones. That's why we write 2 above our tens column, because we've made 2 tens, and 8 as the ones digit of our answer, because we have 8 ones. So now we have 26 tens. But again, we can regroup. 10 tens make 100. So now we've made 2 hundreds, and we have 6 tens. So we can write 2 above our hundreds column, and we can write 6 as the tens digit of our answer, because we now have 6 tens. And we have 6 hundreds, because 1 times 4 is 4, so there's our 4 hundreds, but we made 2 hundreds from multiplying our tens, so we have 6 hundreds altogether. Then we had 879, so that's 8 hundreds, 7 tens, and 9 ones. We were multiplying by 3, so we can show what we have 3 times. Now we have 27 ones, but we can regroup those into 2 tens and 7 ones. So the 2 tens that we've regrouped can be written above our tens column, and the 7 ones goes in our answer. But now we have 23 tens. We can regroup those into 2 hundreds and 3 tens. So because we've made 2 hundreds, we can write 2 above our hundreds column, and we can write the 3 tens that we have left in our answer. Now we have 26 hundreds, but that's the same as 2 thousands and 6 hundreds, because we can exchange 10 hundred counters for 1,000 counter. So we're left with 2 thousands, 6 hundreds, 3 tens, and 7 ones, so that's what we have in our answer. Now our last question was 4 times 867, but with multiplication, order doesn't matter, so we can show 8 hundreds, 6 tens, and 7 ones, and we can show that 4 times, because 4 is the other number in our multiplication. We can regroup 28 ones into 2 tens and 8 ones. So we write the 2 tens that we've made above our tens digit and the 8 ones as the ones digit of our answer. Now we have 26 tens, but 10 tens can be exchanged for 100. So now we have 2 hundreds and 6 tens. The 2 hundreds that we've made can be written above our hundreds digit, and then the 6 tens goes in our answer. Now we have 34 hundreds altogether. 8 hundreds times 4 gives us 32 hundreds that we have here, but we also have 2 more hundreds that we made from multiplying our tens. So these 34 hundreds can be regrouped into 3 thousands and 4 hundreds, because we can exchange 10 hundred place value counters for 1,000 place value counter. So now we have 3 thousands, 4 hundreds, 6 tens, and 8 ones. So that's why our answer is 3,468.